Welcome to the Leistritz webinar discussion on drop-in replacement or re-engineered screw pumps for pumps that are bad acting, old, or have been very expensive to maintain and operate. I'm Kim Robbins and I oversee the marketing for Leistritz, and I'd like to thank you for taking the next 20 minutes or so to learn about our L3 series of products. Joining me today is David Basil. David has been a member of our sales engineering team for 13 years. He attended Carnegie Mellon, where he received his Bachelor's of Engineering, and has an MBA from Rensselaer. When not specifying screw pumps, David is an avid runner and mountain biker. David is our subject matter expert on drop-in replacement pumps, and he's a great person to take us through this presentation. We are recording this session, so you can review it again or send it to your colleagues. Please feel free to use the questions section on the dashboard, and we will either answer your questions live or make sure we reach out to you after the session. I'd now like to hand it over to David, who will take us through the presentation.
Okay, thank you, Kim, and thank you everybody for joining us for today's webinar. And today we're going to be talking about the Leistritz re-engineered 3-screw pump technology. And basically what that is, it's our simple custom solution for the drop-in replacement of old, bad-acting, or high-maintenance cost pumps. What we'll go over today in the next 20 minutes or so is a brief history of Leistritz, then move on to why should a pump be replaced in a plant? What are some of the common issues and problems that need to be solved? What are some of the obstacles to performing this pump replacement? And then we'll talk about the Leistritz re-engineered solution, a little bit about the custom design of our re-engineered pump, and then go into a few case studies. And I'll wrap it up with information on how to request a quote from us, and then hand it back to Kim to talk a little bit about our service and support. So Leistritz has a long history of over 100 years serving its industrial customers, beginning with its founding by Paul Leistritz in Nuremberg, Germany in 1905. They began with the manufacturing of steam turbine blades, followed by the development of screw pumps in 1924 and polymer extrusion machines in 1937. 1973 marked the first presence in the US with a small customer service organization. And then Leistritz Corporation, a full US subsidiary of the German parent Leistritz AG, was formed in 1986. We recently were reorganized into Leistritz Advanced Technologies Corporation, also known as LATC. The LATC Pump Division is headquartered in Allendale, New Jersey, located in the northern part of the state, and our facility handles sales, engineering, and project management for the Americas. We also feature a full service shop and warehousing for stock pumps and spare parts. Okay, so we'll jump right into, well, let me first mention that LATC actually currently consists of 4 divisions: screw pumps, machine tools, turbine blades, and extruders. Okay, now we'll jump into the re-engineered concept and some of the baseline common issues and problems that plants can see that may warrant the replacement of a pump. First, when we speak about pump replacements, there are a number of baseline issues that we encounter. What I'm going to do now is review 5 of the primary examples. The first one is aging. Many refineries, chemical plants, and other facilities we deal with in the US were built decades ago. It's actually not uncommon to find equipment that is 30, 40, or even 50 years old, and at some point it needs to be replaced. And as you can see on the left there, that difficult to read drawing is just a representative of an old hand-drawn photocopy drawing that we might receive from a customer. We're trying to figure out the dimensions of an existing installation that was put in 40 years ago. Okay, so in addition to the aging of pumps, another problem we come across quite often are inefficiencies in the existing pumps due to changes. So existing pumps that were selected based on decades-old process data, and in many situations, operating conditions have changed over the years. Possibly the product being pumped has changed, or there are different pressure and temperature conditions. Often viscosity may also be changed from 40 years ago to now, as the products that come in may be quite different. And any of these changes could mean that the pump is no longer operating at optimum efficiency, and that replacing it would be beneficial for the plant. The third item I have listed there is non-optimal pump type. And here we often run into existing pumps that they're just not a good fit for the application where they're in service. One example is a centrifugal pump that may be placed in high viscosity service. So as a result, they're inherently operating inefficiently. In addition to an example like that, there are non-optimal pumps due to changing technology. 40 years ago, when a plant may have been built, it was common to use timed twin screw pumps for positive displacement applications. And although that's a very good, solid technology, it definitely introduces some complexity with timing gears. Timed twin screw pumps have 4 bearings, 4 seals, and all that complexity is really not necessary for many services. Actually, a large number of these applications could be handled more efficiently with a modern 3-screw pump. The 3-screw pump has a single bearing, a single seal, and as a result is much less costly to maintain. The fourth category I have there are obsolete pumps, and these are just another example of excellent candidates for replacements. We've heard many stories over the years about the difficulty and extremely high cost of obtaining replacement parts for obsolete pumps, and sometimes parts even have to be custom machined. So that is a very common issue out there for pumps that the manufacturer no longer manufacturers. And then finally, we're talking in the general category of bad acting pumps. And they may be the result of one of the categories that were mentioned above, or simply just have a poor history of reliability. But in any case, these pumps are typically the plant's prime target for replacement. So although there are many good reasons, as we just saw, for replacing a pump, there are also obstacles that a plant faces that may require site modifications and associated costs for a typical replacement. Speaking about a few of these obstacles that a plant might encounter would be first the existing piping. If someone was going to get a standard replacement pump, it would likely have different flange locations than the existing obsolete pump, for example. And that would require piping modifications in the plant. Existing piping, it might be old, might be insulated with material such as asbestos, and modifications potentially can require hazardous cleanup and permitted hot work, which is difficult to get approved and expensive to carry out. Another obstacle is the existing infrastructure and foundations. Concrete foundations that are at a plant may be grouted or otherwise difficult and costly to remove, and to reconstruct them would be challenging. Also, possibly there are obstructions or auxiliary piping, electrical conduits or steam piping in the area, and that may also make any kind of construction in the area difficult and challenging. And finally, an obstacle that that plants always encounter would be just the replacement pump cost. Would it be more costly to put in a new pump and make all these changes to the site rather than just keep their old pump in place and just sort of struggle with the high maintenance costs? So these are a few of the replacements, and what I'm going to be talking about is our unique solution that effectively removes these obstacles.
So we're just going to do a quick poll of everybody who is out there, and you can see this. It says, "Hey, help! My pump it's old, it's acting up, or a bad acting pump. It's inefficient. It's not the right type for our application, or it's simply just getting too expensive to maintain and to operate." So if everybody could just take a second and go ahead and answer that. Right, great. So most of you have gone ahead and answered, and 100% of you, everybody out there said it is just simply old. So as well as we've got a series of acting up and not the right type for the application. So there's a combination, but everybody has said the best reason for dropping in a new pump is because it's just outlived its usefulness.
Okay. Great, Kim, thank you for doing that. That's an interesting result. Control here. Get to the next slide. Let's see. Okay, there we go. Okay, all right. Thank you, Kim. So what I'm going to jump into now, we just talked about the problems that may exist at a site that would justify a replacement pump, and we talked about some of the obstacles that are in the way. So now the Leistritz solution in overcoming the obstacles to pump replacement is our reengineered concept. Based on drawings and measurements of the existing installation, we can custom fabricate a pump casing that matches the existing flange locations, regardless of their orientation. So whether you have a side in, side out, side in, top out, axial in, whatever it is, we can match those existing flange locations. We also can match the existing shaft type. So in the case that a driver should be reused, if that's possible, that can be done as well. This will eliminate the need for site modifications of the existing piping or foundation, enabling essentially a drop-in replacement to your old pump. In addition, other complexities such as heating jackets, if that's on your existing pump, can be incorporated into our casing design. Now, in addition to the re-engineered pump utilizes a standard removable pump cartridge of the 3-screw design that contains all of the rotating elements and features that would be required for a specific application. So as you can see from this drawing here, the cartridge simply slides into the casing, and it allows for very easy future maintenance or replacement. Often the customers will stock a spare cartridge, so it could be quickly changed out if necessary. Now, the key here is that in many cases, we may be changing a timed twin screw pump, for example, with a 3-screw pump, and the 3-screw technology features only a single seal, single bearing, for very simple, low maintenance operation. 3-screw also offers high reliability, excellent operating efficiency, and economical pricing. And in terms of the cost barrier that we talked about before, it's actually not unusual for the cost of an installed re-engineered pump to be lower than a single major outage for an obsolete timed twin screw pump. Here you can see on this slide here about our casing design, and using dimensional data from existing pump drawings, often together with site measurements, we can precisely design the replacement casing using 3D modeling. Where it's necessary, we even can use computational fluid dynamics to perform the model flow and velocities through the pump chambers to ensure that everything is flowing properly and everything meets specifications and requirements. Okay, so once a completed pump design is finalized, we come up with a approval drawing. It's sent to the end user for verification and approval. And once approved, it proceeds immediately to manufacture. And our custom casings are manufactured in the USA. Okay, so finally, well, here I'll show a picture of what our cartridge-based pump system actually looks like. And you can see on the right-hand side there is the custom steel casing, which matches the existing pump on site. And on the left is our pump cartridge. And as you can see, that just slides directly into the casing for easy removal. All right, so we'll jump into just a few case studies so you can get some example ideas of real-world applications here. And the first example here is of our re-engineered 3-screw pump is the replacement of a Warren timed twin screw pump pictured on the left. In this case, it was approaching the end of its design life, so it had poor reliability and was incurring very high maintenance costs. Our re-engineered drop-in replacement shown on the right matched the side and top discharge, and the plant saved significant money by eliminating their bad acting pump. This next example is a photo of our re-engineered 3-screw pump that was designed to replace an obsolete sear bath timed twin screw pump. Our customer was able to eliminate the high costs and long lead times associated with the sear bath's timing gears, 4 seals, and 4 bearings. The next example is a re-engineered 3-screw pump that replaced an obsolete IMO C324 pump. As an obsolete pump, parts were difficult and costly to obtain, and our customer was not happy with the IMO's non-cartridge type design, which made maintenance very labor intensive. And they're very happy to have the cartridge-based design, which again just slides in and it can keep a spare on the shelf. Our fourth example here is a re-engineered 3-screw pump that replaced a Gearx gear pump. Our customer was not satisfied with the gear pump technology for their particular application. Our replacement pump improved operating efficiency and greatly reduced the noise level that is common with gear pumps. So this was an example of an actual technology upgrade. And the final example I have here is a drop-in replacement for a Plenty 3-screw pump. In this case, there was no manufacturer support in the US market, so operational information was not available and parts were difficult and costly to source. The plant switch to Leistritz gave them access to convenient US-based support and spare parts. So that's a quick summary of the re-engineered concept and some real-world applications. If you are interested in receiving a quote from LATC, we would just need some basic information to get started. These would require the flow rate that is needed for your application, the suction pressure, discharge pressure, the fluid type, temperature, and viscosity. If we're going to be reusing an existing motor, we'd obviously need to know the operating speed of that motor. And for the re-engineered custom casing, of course, we would need some existing drawings and possibly perform a site visit to take some measurements. And with all that information, we could simply put together a quote for you, and you'd be able to see how that cost would compare to maintaining an existing pump. And with that, I'm going to hand it back over to Kim to speak a little bit about our service.
Okay, thank you, David. Lots of great information. Hopefully everybody is thinking about some of their old pumps and what might have to be done in order to bring your facility up to speed, so to speak. So I'd like to spend a moment going through our available service and support. We're very active in working with our customers after the sale and installation of any of our products. To best serve you, we make sure that we have original Leistritz parts in stock, so replacement or spare parts are just a phone call away. Once a pump is purchased, we can help with startup commissioning and then work with your team to train on both operations and maintenance. Just a note, pumps should be inspected every 2 years to keep it in top working condition, and this is the service that we offer. And lastly, if something were to happen to your pump, we are available for both on-site and in-house repairs. And also, of course, we are not traveling. Nobody is traveling all that much, so we can also do virtual sales calls. We currently have a special that we're running. So you can read that there was one of two, free disassembly inspection, and then a report with a repair order. So that happens for free, or we will return your repaired pump for free. Because of the pandemic, we're not traveling to see our customers, but we are hosting lunch and learns via video where we can even send you lunch. So reach out to set something up with one of our sales engineer team members. Lastly, you'll notice in the handout section that we've uploaded the re-engineered brochure as well as the presentation from today. So please feel free to take a moment and download both. If you look at the chat, there's a link to a form that you can easily fill out, and that will help request a one-on-one meeting so that we will get in touch with you, and you can either get a Yeti Rambler, of which you see a picture, or we can donate to a charity of your choice. So just a little more incentive for you to set up that call with us. And I'd like to thank everybody from David and myself for your attention and your participation. And we certainly look forward to working with you. And we'd like to ask everybody to enjoy the rest of their day and stay safe.